Uh, Today, I will take you through the topic machine learning, which all of us know that this is very recent topic and very new topic of research. I will take you through the introduction to machine learning, then its various applications, then machine learning solutions, types of machine learning, supervised learning, unsupervised learning, and reinforcement learning, and experimental evaluation of machine learning algorithms. Students, we know that machine learning is a mega stride nowadays. Why? Because we come across the applications of machine learning in our day-to-day life. Every day and everywhere we are using machine learning. So day to day we are using the Gmail, okay, and we come across the machine learning in classifying the emails. We know that whatever emails we receive daily that are categorized, classified as a primary emails, social emails, and promotional emails. That is a very good example of machine learning that we come across daily. Then we are using WhatsApp every day. On WhatsApp, when we try to type the message, whenever we start typing the words are predicted. Okay, if we type ELEC, then it will suggest whether it is electronics or election. So that is nothing but the prediction system. And for this also machine learning has been used. Then categorizing and grouping of applications are also used in Android system. Okay. Then when we watch the movies on the Prime Video and Netflix. Depending on our previous history, whatever movies we watched earlier, depending on that, the movies are recommended to us. That is also a very good example of machine learning. That is nothing but the recommendation systems. So, why machine learning popularity is increasing today? Because nowadays we are available with new softwares, new algorithms, new hardware, and we are also available with a big data. Big data is nothing but the voluminous data which is available today. That data can be stored on the uh, memory storage systems, and even we are available with the new hardwares, new algorithms, and with the help of this we can implement and deploy the machine learning systems. Actually, artificial intelligence, machine learning, and deep learning, these are the interrelated fields. Artificial intelligence is nothing but a technique which enables the computers to mimic the human behavior. Whenever we try to mimic the human behavior, means we are making the systems intelligent. So that is nothing but the artificial intelligence. Machine learning is a sub-part of artificial intelligence. It is a technique that gives the computers the ability to learn without being explicitly programmed to do so. And deep learning again comes under the machine learning. It is a subset of machine learning which makes the computation of multi-layer neural network feasible. So all these fields, machine learning, deep learning, artificial intelligence, data analytics, data science, all are dependent on each other. We cannot categorize it separately. These are interdependent fields. We will try to understand the difference between traditional algorithmic approach and machine learning approach. In traditional algorithmic approach, we give the data and program as input to the system and we get the output. Whereas in machine learning, we give the data and output as an input to the system and we get the model or a program as the output. So it will be clear to you in this diagram that in traditional programming solutions, what we do whenever we write a program in Java for getting the particular application executed, what we exactly do in that? We give the data as an input to the program which we write by using the various platforms like C, C++, Java, and whenever we execute that program to which we have already given the data as an input, we get the output. Whereas in machine learning, we use the data as an input, but that is the label data. That is the data which has got the output. That data and labels we give as an input to the system and then we get a program or a model as an output. So we can say that machine learning paradigm is nothing but the system's ability to improve one's behavior based on its experience. Like we know that doctors and lawyers, they learn from their previous experiences. We always prefer to go to the experienced doctor. Why? Because we know that experienced doctor or experienced lawyer learn from their previous or past experiences. If they come across to more number of patients in their life, then they will get the more experience. Similarly, the machine learning systems also learn from their past experiences. The data which we give to the system to learn, that is nothing but their experience. And from that experience, they learn and give the prediction. So, building computer vision that automatically improve with experience is nothing but the machine learning paradigm. A program which is said to learn from the experience E with respect to some class of task T and performance measure P. If its performance on task T as measured by P improves with experience, that is nothing but machine learning paradigm. Prediction and classification are the tasks in machine learning and experience is the data. Machine learning systems are broadly classified in three categories, that is supervised learning, unsupervised learning and reinforcement learning. In supervised machine learning, the data is the labeled data, so we have to give the input as well as output to the system for learning. And if the output is given to learn, then we can get the feedback. So there is a direct feedback available, and with that feedback, they can improve and can give the better predictions for the future data. Whereas in unsupervised learning, we don't give the output or labels to learn, we just give the input and based on that input, the system will try to learn the structure, characteristics of that data. And based on that characteristics, the samples will be categorized in different groups. So, in unsupervised machine learning, feedback is not there. Why? Because there are no labels to the data samples. That's why there will not be any feedback. So, such systems are used to find the hidden structures in the data. Whereas in reinforcement learning, reward system is used The decision process is based on the reward system. So we will now study the supervised learning. Students, you can see from this example, from this block diagram, you can see how the learning takes place in supervised learning. This is the label data. You can observe that this is the label data. Why we call this images as a labeled images? Because with this images we are telling the system that this particular image is of hexagon, this particular image is of triangle, and this particular image is of a square. So this intelligence we are providing to the system as an input to get it learned. So based on this labels and the data samples, the system, this model will be trained. Once the model will be trained, it will be able to categorize the unseen data points, or we can call it as a test data. It will be able to categorize unseen data points which are not seen it before, seen this model before. Okay, so this system, this trained system will be able to categorize this particular image as a square image or a triangle image. So this is the group of data which is used for the training, and this particular test data points have not seen by the system while training. So this is called as the supervised learning. So we can say that in supervised learning, a set of input features like x1, x2, xn, these are the input features, and with these input features we give the target output, that is y. So now in this example, if we try to understand what do you mean by x1, x2. So now see here the image of hexagon, image of square, image of triangle. These are nothing but the input features x1, x2 up to xn. And these labels, this particular image belongs to hexagon, this particular image belongs to triangle. These are nothing but the target feature y. So we can give these input features, labeled features, that is a set of training examples where the values of input and target features are given for each example. And the test examples, these test examples are nothing but the new examples where only the values for the input features are known to you. Now in this diagram you can observe that while testing the model, we are just giving the input features to the system. We are not telling the model that this particular square belongs, this particular image belongs to square or triangle. Okay, that labels we are not giving. So that is the new example, test example, where only the values for the input features are given. And based on the learning, based on its learning, it will predict the values for the target feature for new example. Supervised learning can solve the classification problem as well as regression problem. We will try to understand what is the difference between classification problem and regression problem. Classification problem deals with the discrete output labels, and regression problem deals with the continuous output label. You will be clear with the classification and regression with some example. We will take the example of credit score system, in which we have to classify a particular customer as a low risk customer and high risk customer. Now that can be done based on the two input features, that is the income of a customer and savings of a customer. If a particular customer or a applicant is applying to get a credit card, so based on the income and saving of a person, we can classify a particular applicant or a person in either low risk category or high risk category. So we have got only two categories to classify, that is low risk and high risk. That is discrete category. That's why this particular problem will be a classification machine learning problem. Okay, so based on this two parameters or features like income of a person or applicant or a customer, income of a customer, if it is less than theta, then it will be categorized as a high risk applicant, and if income is greater than theta 1, it will be categorized as a low risk. So if a particular person has got a good income and quite a good saving, then that particular applicant can be a low risk applicant. So this is the model which we are trying to build from the data which we are available with. Okay, so such type of problems belongs to the classification problem. Now next is the regression. In regression, the output is continuous in nature. Like if we try to predict the price of a car based on some of its attribute, some car attributes, if we try to predict the price of a car. So if mileage is given to us, we have to predict a car price. So car price can take any continuous value. It can be 1 lakh, 2 lakh, 3 lakh, it can be 3.5 lakh. So specific categories, discrete categories are not available to us. It may take any continuous value. So such prediction problem belongs to regression problem. Okay. So I hope that you got the difference between the classification and regression problem. So in supervised learning, we are available with the label data. So now, if we have got the income and age of a particular person, and we have to suppose predict that a particular person will buy a computer or not. So we are available with some past data of a person, of a applicant. Okay, what is the data? We are available with the income and age, so that are nothing but the features. Income and age, these two are the features, and we got the labels also, that if particular person has got this income and what this is the age of the person, then he will buy the computer or he will not buy the computer. So whenever we get this data sample, we try to locate it in two-dimensional space. Okay, so once we locate it in two-dimensional space, we can design a hypothesis function or a model for the machine learning system. These are the different classes. So now see student, based on the previous discussion, I would like to ask you that this particular classification problem will belong to classification or regression. This particular problem will belong to either classification or regression. Yes, can anybody answer? Yes, student? Can anybody answer? This particular problem will either belong to classification or regression problem. Yes? Okay.
Please reply.
Uh, Okay, no problem. This is a classification problem because we have got the discrete category, that is we have to categorize a particular person as whether he will buy a computer or not buy a computer. Okay, so that is a classification problem, because there are two categories, either he will buy or not buy. Okay, so we can design a different model for this particular data set. We can design, or uh, we can form the particular model. This can be one of the classifier. Okay, this straight line will categorize a particular person, that he will buy a computer or not. Okay, so this is very simple hypothesis function. This is very simple model. Okay, now we can observe that some misclassifications are there. This is the data, past data, based on which we have just hypothesized one model. And now, if in future, if any unknown data sample is located here, to the right side of the line, then that will be categorized as a yes. And if a particular data sample, unknown sample, future sample is located to the left side of this line, then that will be categorized as no. Okay, so this is how the classification takes place in supervised learning. This is also one of the classifier where there are only there is only one misclassification of yes category and no category. Here you can observe that there is only one red point to the left of this line and only one blue point to the right of this line. This is also one of the hypothesized model which we can get out of the learning. Now see, this is the perfect model, as we can see, which in which we will get the 100% accuracy. But this model is quite complex. Okay, so we are trying to overfit a model. In this case, though we are getting the 100% accuracy in training, but in testing, we may not get the 100% accuracy. So these are the different classifiers which we may get after the learning. Now we will come to the unsupervised learning. In unsupervised learning, class labels of the data are unknown to us. So if class labels are not known to us, then we can use the data sample just to group, or just to know the structure of the data. So the set of data will be given to us, and our task in unsupervised learning will be just to establish the existence of classes or clusters in the data. See, in this diagram, we can observe that how the unsupervised learning can make the grouping of this fruit images. Okay. Now, see, this is unlabeled data. We are calling this data or image as unlabeled image, because it is not known that particular image belongs to apple fruit or Mosambi fruit. Okay, so what this model will do while learning, it will try to group the similar characteristics images. Okay, so after learning, what it has done, it has grouped the similar red colored image as a apple images. It has grouped the orange colored images as a different category. Okay, so we can do the clustering or grouping in unsupervised learning, because the data is unlabeled in nature. That is the basic difference in supervised and unsupervised learning. Now here, this is the unclustered data. These blue dots in an image is the unclustered data, and based on its category, we try to cluster it into three groups: green colored dots, red colored dots, and blue colored dots. These are the three clusters formed after learning. Okay, so that is the basic difference between supervised and unsupervised learning. Now, there is one more category, reinforcement learning, in which there is the agent and environment. Like we do in closed loop system, we always try to get the feedback from the output, and based on that feedback we try to modify the output. Okay, we try to get the 100% accuracy. So similarly in reinforcement learning, there is an environment and agent. So there are some parameters in the environment which we are trying to modify. So environment always give the rewards to the agent. That reward may be positive or negative. Okay. So if there is a positive reward, then agent will understand that there something is good in the environment, and depending on that it will take the action for the environment. And if it is a negative reward, then agent will try to do some modification in environment. So it is a reinforcement learning. Okay. Now see, as far as machine learning is concerned, there are various terminologies in machine learning. First is a feature space. Now, whenever we try to build a two-dimensional or multi-dimensional space in a machine learning, then that is called as a feature space. This is how the label data looks like in the feature space. Okay, so definitely this is a two-dimensional space. On x-axis one parameter is there, on y-axis other parameter is there, and this plus and minus are nothing but its label. Okay, so again it is nothing but the supervised learning problem. So we can see the example. This particular plus data sample has got two values, 0.5 and 2.8, which belongs to the y value. And now the positive and negative are nothing but the past data samples. And once we build a model based on the past data sample, this pink line is nothing but the hypothesis function which we have got after the learning. And once the hypothesis function is modeled, we have to predict some future data or unseen data. So the question mark is nothing but the unseen data which this model didn't see during the learning. So this question, if the question mark falls on this side, left side of the line, so it will be categorized as a positive label. And if this question mark, that is unseen data point, future data point, uh, falls at the right side of this pink line, then we can say that it is a negative category uh, data sample. So this is not actually the only hypothesis function which we can get out of learning. We can get the different hypothesis function. It depends on the parameter which we are using while learning. Okay. So these are the different hypothesis function or a model which we can get out of the learning after learning. Okay. So we have to choose the model which will give us the best accuracy. Okay, so this the set of actually all legal hypothesis function is called as the hypothesis space, and we have to choose the optimal one. Now, as far as machine learning is concerned, you will frequently come across these two terms, bias and variance. So what is the bias? Bias is the difference between the average prediction of our model and the correct value which we are trying to predict. Okay. Now see, what is the average prediction which we get after learning the model, and what is the correct value which we are trying to predict? That is, there is always a difference between that, and that is nothing but the bias. And see, the model with a high bias pays a very little attention to the training data. You can observe in this example. Okay, now see, uh, this line is nothing but our model which we got after learning. Okay, and this is very simple model. We can say that this is very simple model, and in the training itself we can observe that there are two mispredictions. This blue data point is categorized as a red, and this red data point is categorized as a blue. Okay, so in the training itself we can, this is the training data, and in training itself we can observe the two mispredictions. Okay, why? Because see, there is a high bias in this case. Why? Because the accuracy will be less, there will be the more error, because the model is very simple. So when we try to generalize the model, when we get the oversimplification of the model, then definitely there will be the high bias, because whatever uh, whatever average prediction which we are getting and what correct value which we are trying to predict, there will be the lot of difference, and that's why there will be more training error and testing error in high bias, in a model with high bias. Okay, model with high bias pays a very little attention to the training data, and it try to oversimplify the model. It always lead to high error on training as well as testing. Now we will try to understand the variance. Variance is the variability of the model prediction for the given data point. Okay. Now see here, the model is complex. The model which we got out of learning is complex. Okay. So with this complex model, we are trying to overfitting all the data points. But we cannot assure that when it comes to the future data samples, unseen data samples, we cannot assure that it will do the right prediction. Okay, so high variance is always associated with the overfitting of a model, complex model. At the training, during the training, we will get the uh, very good accuracy. We may get the 100% accuracy, but testing accuracy may hamper with the model with high variance. Okay, so model with high variance pays a lot of attention to training data and does not generalize on the data which it has not seen before. And as a result, what will happen? Such model may perform well on training data. We may get 100% accuracy while training, but definitely it will hamper the testing accuracy. Now see, in any engineering system which we try to develop, we once the system is developed, we always try to test the system. Okay, so there are some performance evaluation parameters decided while designing the system, and once the system is developed, we use those performance evaluation parameter for testing of our model. Okay, similarly in machine learning also there are some performance evaluation parameter, and that evaluation is important because the systems which are designed, that are designed to predict the class of some future unlabeled data points, we always try, we are designing the system to deploy it somewhere at the very important paradigm. Okay, so evaluation parameters are very important as far as performance of our machine learning systems are concerned. So typical choices of when we design an amplifier, we always try to find its gain. Okay, and after finding the gain, we can say that our amplifier is good. Okay, we try to find its bandwidth. So similarly in machine learning systems, there are some performance evaluation parameters. So typical choices of performance evaluation parameters are error, accuracy, precision and recall. Okay, so and there are some sampling methods of data, because when we get that, see, the data is very important for machine learning systems. Okay, because based on the data, the systems can be designed properly. So the data we have to manage properly. So what we do in machine learning, we try to sample the data. We reserve some data samples for testing and for some for training. Okay, so there are some typical choices of sampling methods also. We can reserve some sample data points for training and some for testing. Similarly, there is some more methods are there. K-fold cross validation is there, then leave one out cross validation is also there. Okay, so these are the typical sampling methods. And then see how there is a difference between the evaluation of classification problem and regression problem. Okay, so in regression problem the evaluation is based on the absolute error. So what we do, that suppose y is our output, y is the observed value of the target feature on example x, and y cap is the predicted value of target feature on example x. So the hx is nothing but the hypothesized output and y is the actual output. So difference between these two will give you the absolute error, and that error we summarize. We take a sum of all those errors over all data points and we get the mean square error, sum of square error. So sum of square error is very important performance evaluation parameter as far as regression problems are concerned. Okay, then in classification problem we try to count the number of misclassifications. Okay, so if h of x is the hypothesized model, hypothesized output, and y is the actual output, so if both of these output match, then this function delta will return 1, and if hypothesized output and the actual output doesn't match, then delta will return as 0. And just by observing this 1 and 0 we can come to know that how many misclassifications has been there. Okay, so just after counting the number of misclassifications we can form this matrix which is called as a confusion matrix. Okay, so see this, if there are only two output classes in our classification problem, then if one is positive class and other one is negative class, so these two are the horizontally, these row are suppose the true classes and vertical columns are nothing but the hypothesized class. Then true positive, this integer value, this true positive integer value will give you the number of classifications which are actually positive and hypothesized as a positive. Okay, and true negative is nothing but the number of data points which are actually negative and hypothesized as a negative points. Now what do you mean by false positive? False positive means actually true class of the data point is negative but our model has predicted it as a positive. Similarly, in false negative case, the number of data points who are actually positive but our hypothesized model, our designed model has predicted it as a negative. So based on this matrix we can get many parameters like accuracy. So accuracy is nothing but the integer value of tp plus tn divided by p plus n is nothing but the total number of data points which we are using for the testing. Okay, so this ratio will give you the accuracy. Similarly, precision is nothing but the correctly classified positive samples over the total number of positive samples. That will give you the precision. And recall is nothing but the total number of positive TP, that is positively classified samples over the total number of positive samples. So these three parameters, accuracy, precision and recall, these three parameters helps us to evaluate the performance of our model which we have designed after the experimentation in machine learning. Okay, now difficulty in evaluating the limited data. Now see, there is always a problem of data, availability of data in machine learning scenario. Okay, if the data which is available to us is significant enough, then we can get a proper model. Okay, but if the data is not uh, enough, then with that limited data it may be difficult for us to design a particular model in machine learning. Okay, so whatever data is available to us, if it is limited, then we have to use it properly. Okay, so what we do, uh, we cannot use all the data for training. We have to reserve some of the data samples for testing. So if used all the data for training, what will happen? We will get the bad estimate of the error. Okay, we will not get the proper accuracy. So because there should be some independent set of samples reserved for training as well as testing. Okay, but if the size of the data sample is limited, then cross validation is the method by using which we can get the proper estimate of our error. Okay, so in cross validation, what we do, we the available data set, suppose if d is 100. Okay, so available, we have got the 100 samples in our data set, d is equal to 100. Then we can reserve 80 samples for training and 20 samples for testing. We can vary this ratio. Okay, you can reserve 70 for training and 30 for testing. Okay, so that we do in cross validation. This method in hold out cross validation, it is mainly used when the data set D is large enough. But if it is too limited, then we can use k-fold cross validation, in which in every round what we do, we we reserve some fixed number of samples for validation, and all others will be reserved for training, and we change that ratio in every round of training. So if we are doing the 10 rounds of 10 iterations of training, then in every iteration we are changing the number of samples reserved for the validation and training. Okay, and final accuracy is average of all iteration. In leave one out cross validation, what we do, in every iteration we reserve only one sample for training and n minus one samples for training and only one sample for testing, and that changes we do in every iteration. Okay, so total number of iteration, if there are n number of samples, then total number of iterations will be n minus 1. Okay, so leave one out cross validation is used when the number of samples available are very low. Now, as far as machine learning algorithms are concerned, uh, broadly it is classified as supervised learning and unsupervised learning. Okay, so in supervised learning, we have seen that classification and regression can be two problems. Okay, so in classification, support vector machine, discriminant analysis, naive Bayes, nearest neighbor, neural networks, these are the various algorithms which are used for classification. As far as regression is concerned, then linear regression, SVR, GPR, ensemble methods, decision trees, neural networks. These are the various algorithms which are used for regression. Then, as far as clustering is concerned, unsupervised learning is concerned, which is used for clustering and grouping. K-means, K-medoids, then fuzzy, C-means, hierarchical, Gaussian mixture, hidden Markov model, neural networks. These all are used, these algorithms are used for clustering. We will discuss the support vector machine. Support vector machine, basically it is used for supervised machine learning algorithm, SVM. You have frequently come across this term, support vector machine. It is used in supervised machine learning problems. It can be employed for both classification as well as regression, but frequently it is used for classification problems. Commonly used SVM algorithms are linear, then kernel functions are the SVM methods. Then based on the idea of finding a hyperplane, this machine learning algorithm is built. Okay, now see, in this diagram we can observe the data points in this two-dimensional space. there are some yellow data points and blue data points. Okay, yellow data points belongs to one class and blue data points belongs to other class. For this particular data points to classify, we can form these three hyperplanes. Using SVM, we can form these three hyperplane, hyperplane 1, hyperplane 2 and hyperplane 3. We have to, these are the possible hyperplanes, but we have to choose the one which will give us the optimal result. Okay, so actually in SVM, in support vector machine, we try to build one hyperplane which is nothing but a line that linearly separates and classifies a set of data points. Here also we can observe that in this two-dimensional space there are only two classes based on we have to classify a particular data point in either of these two classes. Okay, the data point should, the particular data point after designing of this hyperplane, a particular data point should be actually as far as away from this hyperplane. There should be a large gap between the data point and this hyperplane. Okay, so actually we call it as a margin, and the margin should be as high as possible. Margin is nothing but the distance between the data point, nearest data point and the hyperplane. So data point should be as far away from the hyperplane as possible, and it should be still at the correct side of the hyperplane. When new testing data point is added, when we try to use this particular designed hyperplane model for testing a future sample or unseen sample or a sample, test sample, then whatever side of the hyperplane it lands, that will decide the class that we assign to that sample. So in this case now we can observe that this is the hypothesized hyperplane which we have got after the learning, and the distance between the hyperplane, this hyperplane, and the nearest data point from either set is known as the margin. And what is our goal in support vector machine? Our goal is to choose a hyperplane with the greatest possible margin between the hyperplane and any point with the training set, giving a greater chance of new data being classified correctly. So in SVM, whenever we design this hyperplane, whenever we design this model, our aim is to have the greatest possible margin between the hyperplane and any point within the training set. So this yellow line is nothing but the margin. Okay, now see, this is okay with the linearly separable data set. Now see, in this two-dimensional space, we can observe that these data points are very easily separable by this straight line, by this linear line. But what about the non-linearly separable data set? Now these data points, we can observe that they are not linearly separable. They are linearly non-separable data points. Okay, so how to hypothesize this data points, how to develop a model for such data points? So for that, kerneling trick is there. Okay, Suraj sir will better explain you the kerneling scheme. Okay, Suresh sir will better explain you the kerneling scheme. Now see, in this two-dimensional space, we can observe that these data points are not linearly separable. So what we can do, we can convert these two-dimensional data points into the three-dimensional data point, as you can see. So that is called as the mapping of the data points into the lower dimension into higher dimension, and actually this is known as the kerneling. And now we have observed that linear line in two dimension cannot linearly separate this data point. So now after converting this two dimension into three dimension or multi dimension, we can observe that with this red color plane, these data points are now separable. This is called as the kerneling scheme. The data will continue to be mapped into higher and higher dimension until we get a proper hyperplane to separate these data points. Okay. So in this diagram now you can observe that these are the linearly separable data sets and these are linearly not separable data sets. So a soft margin can be designed which will separate these data points, but it will have to tolerate one or few misclassified dots. Okay, so instead of designing a soft margin, we can go for the kerneling trick, where we can observe that these are the kernels. Okay, this is the polynomial kernel. Okay, and this is the RBF kernel, which can deal with the non-linearly separable data set. Okay, so utilizing existing features which applies some and after applying some transformation and creating a new feature, those new features are the key for SVM to find non-linear decision boundary. Okay, so polynomial and radial basis function kernels are the most popular kernel functions for non-linearly separable data